contains Pn minus 2, and in the end it contains P0, which contains the empty set. So when this is x1 different from 0, and when you have x0, x1 equal to 0, and here you have x0 equal to 0, and of course when all of the xi's are 0, by definition of projective space, you get the empty set. And so the difference at each level, PD minus PD minus 1, is AD. And so you have exactly one generator. You have one generator of degree n, one of degree n minus 1, and all the way down to degree 0. And again, in fact, this will be an isomorphism. In fact, but we will prove later, not so much later, that in fact AD Pn is cyclic for. So what other what other schemes beside projective space can you apply this to? For instance, if you are at all familiar, example, the Grassmann variety, all Grassmann varieties have such a cell decomposition. It's usually goes under the name of Schubert. So this is a key step into the study of what we will see is the enumerative geometry of such subvarieties. So here is the point of this theorem is this is the first theorem, which is really about computing Chow groups. Tells you that indeed they are much, much simpler than cycle groups. And it tells us that they are not so big, or at least in some cases we have an understanding. And so the next time what we will do is we will prove the missing case, and with this we will conclude the part I'm going to do of chapter 1. It's certainly not all of that there is in chapter 1. It's a personal choice. And I will also include some exercises. Again, you can find everything you need inside the book. But for those of you who like to think and to test that they are actually understanding what's going on, there will be exercises. And I hope you didn't hear too much my roommates making noise in the background.